All right, we're going to go ahead and look at doing the ideal gas law. So let's go ahead and read the problem. We have 50 liters. Container holds 45 moles of gas at a temperature of 200 Celsius. We want to find the pressure. So for this problem, we have volume for liters, moles for N, temperature, and pressure we don't know. So we can kind of follow what we know. P we don't have. V is the volume, 50 liters. N is number of moles, so we have 45 moles. R is going to be a constant, so R is always the same value. We look back at our notes, our R value is always going to be this value here, 0.08206. So 0.08206. And then the units are a little bit weird, but it's liters, atmosphere, mole, Kelvin. So this is kind of telling us what we need to put into it. We need to put in liters, so we got liters. We need to put in moles, we've got moles. For temperature, T, we need Kelvin. So we have 200 Celsius, we're going to add 273 to give us Kelvin. So this would be 473 Kelvin. So Kelvin matches here, and then we're getting an answer in atmosphere. So we don't know what it is, but it's going to be atmosphere when we get it out. So that's kind of how the units work with this. It's telling us what we put in. Liters, atmosphere, mole, Kelvin. Liters, atmosphere, mole, Kelvin. All right, to solve for this, we're going to solve for P. So if we look at the next page, we have a couple different equations. So this is something that we can use. We're solving for P. We're just going to use this one here where it's already rearranged. So P is nRT over V. So P equals nRT divided by V. And we just plug in what we know. So our pressure, P, is going to be our 45 times the value of R times our T, all divided by our V, which is 50. So when we put this in our calculator, we're going to multiply the top and divide by the bottom. So we'll do this in frame. We're going to do 50 multiplied by, let me see, here we go. So we're going to do 50 multiplied by 0.08206. Then again, we're going to multiply by the top number, 473. And then we divide by, so division, 50. So we're going to get an answer of 38.81. So the pressure is 38.81 ATM. All right. So this is going to be more of the same. All right, let's look at question 2. So question 2, we're trying to figure out how many moles of gas are liters, 300 Kelvin, 200 atmosphere. So we're given moles, so we know we're looking for moles. N, they give us liters. So V, they give us a temperature of T of 300, and atmosphere is going to be our pressure. So PV equal PVN nRT, and then we'll just fill in what we know. Pressure is 200 atmosphere. Our volume is 30 liters. Our N is number of moles. We don't know what that is. R is always the same. And then our temperature is 300 K. All right, so then we plug in. We're going to solve for N, so we're looking for N. So let's go back to our equation sheet on the next page. So if we're solving for N, N is going to be PV over RT. So N equals PV over RT. And we can just plug in what we have. So our N is going to be 200 times 30 divided by R times our T300. So again, we multiply the top and then we can divide by this. So instead of doing the bottom with parentheses, you do this one times this one divided by this one divided by this one. And that'll make your life a little bit easier to solve. All right, so 200 times 30 divided by 0.08206 divided by 300. So we're going to get a total of 243.72. So our N is 243.72 moles. All right, cool. So let's look at our last one. I have a balloon that can hold 100 liters of air. If I blow this balloon up with 3 moles of oxygen at a pressure of 1 atmosphere, what is the temperature of the balloon? So again, volume, moles, pressure, temperature. Volume, 100 liters. Pressure was 1 atm. Our N is 3 moles. R is 0.08206, and T is our temperature, which we don't know. So let's look at our sheet. We're solving for T. So we're going through, why is this so light? T is P times V over R NR. T equals P times V over NR. Then we just solve. So we're going to put in our temperature is the pressure, 1 times volume 100 divided by 3 times our R. And we can just do this. So top number is just 100 divided by 3 divided by 0.08206. So we're going to get a temperature of 406.21 Kelvin. All right.